Hello, it's Matthew here and welcome to the video. We're looking at question 10, which is worth 50 marks. So a survey was carried out that investigated the amount and type of exercise that adults in Ireland are taking in 2022, and we're asked to write down one advantage and one disadvantage of carrying out a survey on a sample. So carrying out a survey on a sample means rather than surveying the entire country, you just pick a group of people in the country and get their opinions. So, for example, you could choose 1,000 people and you could ask them to fill out a survey rather than asking every single person in the country. When you survey the entire population, this will obviously take much longer. We do this in Ireland every 5 years in the census. So, an advantage of carrying out a survey on a sample is that it's much faster, much cheaper, and much more practical. So, for example, if you're asking 1,000 people to fill out a survey, that's going to be much quicker than asking the entire country of Ireland to fill out the survey. So there's plenty of different things you could say here. As I said, it's cheaper, it's faster, and it's more practical. I'm going to write down it's faster, but feel free to write down another example such as cheaper or more practical as well. You will get full marks for both. And a disadvantage might be that you have a sampling bias. So for example, if you are doing a survey and you have a sample of, for example, 1,000 people, you have to make sure that those 1,000 people are representative enough of the entire population. So you don't want the sample to be too old, too young, to have too much men or too much women. You want a good balance of everything, and you want a balance across the entire country. So you don't just want people in the cities or people outside the cities, you want both. So we call this sampling bias. So if you had too many people over the age of 65 or too many people under the age of 30, that would all be known as sampling bias or anything that's similar to that. If the sample isn't representative enough, that is what we call sampling bias. So there are answers for question A, and that was worth 5 marks. Now let's have a look at part B. So 1,500 people took part in the survey and were asked to show that the margin of error is 2.6%. So the formula for the margin of error is given by 1 over the square root of n. There is a different formula in the formula book that's the standard error of the mean, and that's where you have sigma, which is the standard error above the square root of n. When you don't have the standard error, you can just take the margin of error to be 1 over root n. So our n here is going to be 1,500. So n is always the number of people in the sample. And as I said, here we have 1,500 people taking part in the survey. So therefore our sample size is 1,500. So the margin of error will be 1 over the square root of 1,500. So now let's put this into our calculator and hopefully it'll be equal to 2.6%. So click the fraction button, then click 1, then click the down arrow up here to go to the denominator underneath, and then click this button here for square root, and then 1,500. And once you have that in, click equals to, and you should get 0.025819888897. So 0.0258, that's as a decimal. And remember to convert a decimal to a percentage, multiply it by 100. So multiplying that by 100, we get 2.58%, which to one decimal place is 2.6%, as the 8 will bring the 5 up to 6. So therefore, the margin of error is 2.6%. And that was worth 5 marks. Now let's have a look at B part 2, and we're told that 71% of the sample said they walk, and now we have to find the number of people from the sample who said they walk. So we had a sample of 1,500 people. If 71% of the people walk, then we can multiply that by 71%, and that will give us the amount of people who walk for recreation. So we can just type in 1,500 and multiply that by 71%. So multiply by, and then 71. Now to get the percent button, you click Shift and then click Answer, and that should have the percentage button in yellow, or this percentage sign I should say, in yellow above it. Now just be careful, as if you have the older Casio calculator, it's not that button, it's the button for the open bracket sign. So be careful there. If you don't have this calculator, the button for the percentage sign is different. You still click Shift, but you click the open bracket button instead of the answer button. So then once you have that in, you can click equals to, and we get 1,065. So that means 1,065 people walk for recreation. And that was also worth 5 marks. Now let's have a look at B part 3. And this says, using the percentages in B part 1 and B part 2, write down a 95% confidence interval for the percentage of adults in Ireland who walk for recreation. So a confidence interval is given by, so your proportion will be in the centre, your true proportion in the centre, and to the left of that we're going to have our sample proportion, which I'm going to denote as p hat, and it's going to be p hat minus the margin of error, and then to the right of that you're going to have p hat plus the margin of error. We worked out the margin of error in B part 1, that was 2.6%, and we were told that 71% of people walk for recreation, so therefore the proportion of people who walk for recreation is 71%, so therefore p hat is 71%, and the margin of error is 2.6%. So our confidence interval will be 71 minus 2.6, and that's going to be smaller than p, which will be smaller than 71 plus 2.6. And now we can take away 2.6 from 71, and that will give us 68.4%. And we can add 2.6 to 71 to get 73.6%. So therefore, the true proportion of adults who walk for recreation in 2022 is between 68.4% of adults and 73.6% of adults. Now, one thing here that might confuse people is that this is plus the margin of error. I don't have to multiply this by 1.96 as the 1 over root n has already taken care of this. However, if you use the standard error of the mean formula, which is the standard deviation over the square root of n, you must multiply it by 1.96. So a lot of the time, you'll have to use the formula, the standard deviation over root n, which you will have to multiply by 1.96 for a 95% confidence interval. However, if you work out the margin of error, 1 over root n, then you don't have to multiply it by 1.96. That is a common mistake, so just watch out for that. And now we'll have a look at B part 4. So in B part 4, we're told that according to the 2019 Irish Sport Monitor report, 65% of the adults in Ireland walked for recreation. So we're asked to carry out a hypothesis test at the 5% level of significance and find out if the figure of 65% has changed in 2022 based on the survey. So we have to state our conclusion and also give a reason for this conclusion. So the hypothesis is going to be, so H0, the null hypothesis, is going to be that it is still equal to 65%. And the alternative, H1, is going to be that the proportion of adults who walk for recreation is no longer equal to 65%. So we'll have a look at the confidence interval from B part 3, and we found that the true proportion of adults in Ireland who walk for recreation in 2022 is between 68.4% and 73.6%. So clearly, 65% is not between 68.4% and 73.6%. So therefore, the percent of adults who walk for recreation has increased since 2019, and it's no longer equal to 65%. So the conclusion is that we reject H0, which is the null hypothesis, and conclude that the figure of 65% has changed in 2022 and more people are now walking. So now we have to give the reason for that, and the reason for this conclusion is that 65% is outside the 95% confidence interval, and that's what we found in B part 3. And that's the answer for B part 4, and B parts 3 and 4 were worth a combined 10 marks. Now let's have a look at part C. So we're told to assume that 20% of adults in Ireland jog for recreation, 3 adults are picked at random, and we have to find the probability that exactly one of these jogs for recreation. So whenever you see find the probability that exactly 1, now it might not be exactly 1, it could be exactly 2 or exactly 5 or exactly none of them, but whenever you see the exactly and then a certain amount of them, you should be thinking, can I use a Bernoulli trial here? And to check if we can use a Bernoulli trial, we must make sure that a certain number of conditions are satisfied. One of these conditions is that there must be a fixed number of trials. In this case, a trial will be that an adult jogs for recreation. And in this case, we do have 3 adults picked. So therefore, we have 3 trials. So therefore, there are a fixed number of trials. The next one is that the probability must stay the same for every single trial. So that would be that every single adult, picking an adult, they have a 20% chance that they jog for recreation. And because 20% of adults in Ireland jog for recreation, when you pick one at random, there's a 20% chance that that particular person jogs for recreation. So therefore, the probability stays the same every time. The third one is that the trials are independent of each other. So that means that if one adult does jog for recreation, that has no impact on the probability of the next adult jogging for recreation. So in this case, that's completely true, as these 3 adults are picked at complete random, so they always have 20% chance of jogging for recreation, so therefore the trials are independent. And the last one then is that there must be 2 outcomes, and here we clearly have 2 outcomes. Either the adult jogs for recreation or does not jog for recreation, so there are 2 outcomes. So therefore each of the 4 conditions are satisfied, and that means that we can use a Bernoulli trial to solve this question. So let's try and do this question now with a Bernoulli trial. So a Bernoulli trial looks like this, where n is the number of trials, or is the number of successes. So in this case, a success will be the number of adults who jog for recreation. Q is the probability that someone doesn't jog for recreation, and P is the probability that they do jog for recreation. So n in our case is the number of trials, as I said, and in our case that's going to be 3. Or is the amount of successful outcomes that we want, and in our case we want exactly 1. So therefore or is going to be equal to 1. P is the probability that someone jogs for recreation, and that's 20%. With the Bernoulli, I like to put the percentages as a decimal. So I'm going to change that to a decimal, and 20% as a decimal is 0.2. And now Q is the probability that someone does not jog for recreation. So if someone has a 20% chance of jogging for recreation, to find out the probability of them not jogging for recreation, we can just do 100% minus 20%, and 100% minus 20% gives you 80%. As there's only 2 options, so if you're not going to jog for recreation, then you don't jog for recreation. So there's an 80% chance that you don't jog for recreation. And as I said before, I always like to change these to a decimal, and 80% as a decimal is 0.8. So now I have my N, or P, and Q. Let's fill them in. So N is 3, or is 1, P is 0.2, or is 1 again, and Q is 0.8. That's going to be to the power of n minus or. So n minus or here is 3 minus 1, or 2. So now we can pop this into the calculator. Now people often get confused about how to put in the 3 choose 1. So that isn't 3 over 1 in a fraction, it's 3 choose 1. So from 3 options you're choosing 1. And I'm going to show you now how to put that into the calculator. So first of all click 3, then click shift, then click the divide button, and the divide button has N, C, or written in yellow above it, and the C there stands for choose. So let's click that, and then type in your 1. So you should have 3C1, and click equals to, and you get 3. So therefore 3 choose 1 is equal to 3, and next we have 0.2 to the power of 1, but anything to the power of 1 is just whatever you have, so that's just going to be 0.2. And next we have 0.8 squared, so we can do 0.8 to the power of 2, and that gives us 16 over 25, or as a decimal. And to change it to a decimal, click this S to D button here, just above the delete button, and you get 0.64. So it's 3 by 0.2 by 0.64. And that gives us 48 over 125, or 0.384 as a decimal. So the probability that exactly one of the three adults jogs for recreation is 0.384. So that's our answer for part C, and that was worth 5 marks. Next, we'll have a look at part D, and part D tells us that Sinead is joining a gym and she will be able to use the gym and also go to classes. So she could pay for individual classes at €6 a class. There's a 30% chance she will go to no classes every year. There's a 60% chance she will go to one class a week, so that's 52 classes a year. And there's a 10% chance she will go to 2 classes a week, so that's 104 classes a year. So now we have to use the figures to work out the expected value of the cost of the classes for a year. So be careful, it's the expected value of the cost, not the expected amount of classes she'll go to. So we'll just do the 3 different options first of all. So if she goes to no classes, how much will that cost her? Well, obviously she's going to go to no classes, that's 0. And then it costs €6 per class, it's going to be 0 by 6, and that's obviously 0. So that's not going to have any cost to her, obviously. And if she goes to 1 class a week, so that's 52 classes in the year at €6 a class, so 52 by 6. And that gives us 312. And finally, if she goes to 2 classes a week, so that's 104 classes in the year at €6 each, multiply that by 6. And 104 by 6 is 624. So now we have to get the probability of each of the 3 different options. So the probability of her not going to any class is 30%, which is equal to 0.3. And I am going to change this into a decimal. I do prefer working with decimals, but feel free to keep it as a percentage if you so wish. And the probability of her going to 1 class every week is 60%, which is 0.6. And finally, the probability of her going to 2 classes a week is 10%, which is equal to 0.1. So as I said, I find it's easier to work in decimals here. However, do feel free to keep it as a percentage if you find that easier. So now to work out the expected value or the expected cost of something, you multiply the probability of that particular thing happening by the value or the cost of that thing. So we'll start with no classes. So the probability of her going to no classes is 0.3 or 30%. That's going to cost her €0. So it's going to be 0.3 by 0. And now we're going to do 1 class a week. So the probability of that is 60% or 0.6. And that would cost her €312. And finally, 2 classes a week, there's a probability of 10% of that or 0.1. And it would be 0.1 times by €624, as that would cost her €624. Now when you get to 3 of these, you're going to add them all together. So let's try that now. So 0.3 by 0, anything by 0 is always 0. So that's what's going to be 0. Now we can do 0.6 by 312. And that gives you 936 over 5 as a fraction. Click the S to D button just above the delete button to change it to a decimal. And that gives you 187.2. And then finally we can do 0.1 by 624. And that gives me 312 over 5, or as a decimal, 62.4. Now we can add 187.2 with 62.4, and that gives me 1,248 over 5, or €249.60. So the expected value of the cost of the classes for a year is €249.60. So that's our answer for part D, and that was worth 10 marks. Now let's have a look at the final part of the question, part E, and we're told that there are 2 price plans for the gym. So with silver, you pay €420 up front, and then you pay €6 for every class. But then with gold, you can pay €670 for the year, and you get all classes for free. So we're asked to work out the smallest number of classes that Sinead would have to go to in the year, so that the gold plan would cost less than the silver plan. So obviously, if you're not going to go to that many classes, silver is probably cheaper. But if you're going to go twice a week or 3 times a week, I'd imagine that the gold one is probably cheaper. But our job now is to work out how many classes will Sinead have to go to before the gold one is better value than the silver one. So for the silver one, it's €420 a year. So it's €420 no matter how many classes she goes to. So we're going to call that 420 plus, and then €6 for every class. So it's going to be plus 6 by n, where n is the amount of classes that she goes to. So that's the silver one. And now for gold, it's €670 no matter what. So now we need to find out where 420 plus 6n is greater than 670. As once the 420 plus 6n is greater than 670, then Sinead is better off going with the gold plan as opposed to the silver plan. So we need to solve the inequality for n. So the first thing I'm going to do is going to take away 420 from both sides. So 420 plus 6n minus 420, both of the 420s will cancel, and I'll be left with 6n. So then I get 6n is greater than 670 minus 420, and 670 minus 420 is 250. So now I have 6n is greater than 250. I don't want 6n greater than 250, I just want n greater than some number. So to get rid of the 6, I'm going to divide both sides by 6. So 6n divided by 6 is just n, and 250 divided by 6 is 250 over 6. And we can do that on the calculator. So click the fraction button, and then 250 over 6. And that's 125 over 3, but as a decimal, and we can get that by clicking the S to D button. We get 41.6 with the dot above it, which is 41.666666 continuous. So that can be rounded up to 41.67. So when n, which is the number of classes that Sinead goes to, is greater than 41.67, the gold plan costs less than the silver plan. So therefore, the smallest number of classes that Sinead has to go to in the year is 42. So if Sinead goes to 42 or more classes, then it's cheaper for her to go with the gold plan. But if she goes to 42 or less classes, she's better off going with the silver plan. So that's our answer for part E, which was worth 10 marks. That's the final part of the question and the end of the video. Thank you very much for watching, and I hope I helped.